Hello everyone. Today I am going to teach you glycolysis. It is also called indent May-Hoff pathway. May-Hoff scientists who discovered the pathway. Before going to discuss about glycolysis, first let us see metabolism. Metabolism is the advanced part of biochemistry. Actually, these things are under biochemistry. Biochemistry, metabolism is divided into two: catabolism and anabolism. When we say catabolism, it means breaking down. Okay, breaking down of larger biological molecules. For example, carbohydrate, CHO, carbon, hydrogen, oxygen, because carbohydrate contains carbon, hydrogen, and oxygen molecule, and then proteins and lipids, the main food sources. When you say anabolism, means building up or making or synthesis of biological molecules. There are different kinds of biological molecules. These the things which are building are maybe these larger molecules, this one, or other biological molecules, but simply anabolism is building up or making the biological molecules. The two main catabolic pathways are glycolysis and TC. I want to write first Krebs, because to acknowledge the scientist who discovered the pathway. The scientist Krebs, so Krebs cycle or tricarboxylic acid cycle or TCA cycle or citric acid cycle. For today, I will focus on glycolysis. This is very important catabolic process, which is the starting point for breakdown of carbohydrates. The name is derived from two Greek words, glycis, which means sweet or sugar, or also glycos, which means the same meaning, sweet or sugar, and the other part is lysis part. Lysis means splitting or breaking or dissolution. The facts about glycolysis are: it takes place in organelle cytosol, or cytosol, we call it in another name cytoplasm. The other fact is it is aerobic, both aerobic and anaerobic. That means it can take place in the presence of oxygen. Oxygen is there. In this case, there is no oxygen. Okay, no oxygen. This is important feature of glycolysis, because in this condition, in anaerobic condition, organisms need always ATP. In that case, ATP comes from this pathway. Okay, this pathway, that is glycolysis. The other fact about glycolysis is there are two stages. It is two-stage process, mainly a preparatory stage is first one, preparatory stage, or investment stage, and pay off. What is invested here will be paid off. So pay off or harvesting. So the resource to invest here is ATP, and the resource again harvesting is also ATP. Because the main target of glycolysis is making ATP. So to make more ATP, it should invest the few amount of ATP in the preparatory phase. The other fact, which is very simple, is the pathway, which is consists of 10 steps. The pathway consists of 10 steps. 10 steps in glycolysis. The first step is glucose, the 6 carbon compound. Let each circle as 1 carbon. So carbon 1, carbon 2, carbon 3, carbon 4, 5, 6 will be converted into glucose 6 phosphate. Glucose 6 phosphate. So 6 carbon again here, because glucose is here, 3, 4, 5, 6. In addition to 6 carbon glucose, there is what? Phosphate here. At which carbon? At 6 carbon. If you remember from here, 1, 2, 3, 4, 5, 6. Then at the 6th carbon there is phosphate bond. So this 6 indicates what? Yes, it indicates at the 6th carbon there is what? Phosphate. This phosphate. The next step will be just this compound, glucose 6 phosphate. Let's abbreviate it as glucose 6 G6P. So this glucose 6 phosphate will be converted into fructose 6 phosphate. It is actually isomerization. Fructose 6 phosphate. Fructose 6 phosphate, let's abbreviate it as F6P. It is isomerization process. In the third step, this compound, this metabolite will be converted into 6P, will be converted into what? Fructose 1, fructose 1, 6 bis phosphate. Look, it says what? Bis. It is not bi. Bi means 2. Bi means 2. In this case, it says bis. S is there because there are 2 phosphates. Why it is not bi? Because look, this compound, this one is 6 carbon compound, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, at 6 carbon there is P. In this case, plus to the 6th carbon. At the 6th carbon, again at the first carbon there will be P. How many P's are there? 2 P's. 1, 2. 2 phosphates are there, and it says bis. It says bis because here this compound is between the phosphate group. The phosphates are not bonding each other. So we should say bis, not bi. Let's abbreviate this as fructose 1, 6 bis phosphate line. Then in the fourth step, this compound will be broken down into 2. Fructose 1, 6 bis phosphate will be broken down into 2 compounds such as dihydroxyacetone, dihydroxyacetone phosphate, and glyceraldehyde 3 phosphate, and glyceraldehyde, glycer, aldehyde 3 phosphate. Later these are commonly established DHAP, this one G3P. In the fifth state, these compounds will be isomerized each other. So this one is 3 carbon compound, because the 6 carbon compound, which is fructose, is breaking down into 3 carbon compound, 2 3 carbon compounds. Okay, this one is 3 carbon. So this one is 1, 2, 3. At the third carbon there is phosphate, glyceraldehyde 3 phosphate. Again, this one is also having 3 carbon. Then isomerization between this one. In the fifth state, the isomerization of dihydroxyacetone phosphate and glyceraldehyde 3 phosphate. Consider that glyceraldehyde 3 phosphate will enter into the next process. In the pathway, in the next step, this will not directly enter into the fifth state. Therefore, isomerization is important. This compound should be converted into this one to enter into the next step. In the sixth step, this compound, glyceraldehyde 3 phosphate, will be converted into 1,3 bis phosphoglycerate. Okay, 1,3 bis phosphoglycerate. In this case, look, in this case, glyceraldehyde 3 phosphate are the third carbon, 1 phosphate. In this case, how many phosphates are there? There are 2 phosphates. Bis phosphate. Phospho means 2 refers to phosphate. Therefore, the compound will be, let's write first, 1,3 bis phosphoglycerate. Having 3 carbon as the first carbon, and as the third carbon there is P, phosphate. This one is P to indicate phosphate bond in the first carbon and in the third carbon. You can number 1, 2, 3, 1, 2, 3. This one is a similar way. And in the seventh step, this compound 1,3 bis phosphoglycerate will be converted into 3 phosphoglycerate. 3 phosphoglycerate. And in the eighth step, let us write this as 3PG, 3 phosphoglycerate. And in this case, these 3 phosphoglycerate, 3PG, will be converted into 2 phosphoglycerate. In the ninth step, this, let us write this one as 2 phosphoglycerate as 2PG. This 2PG will be converted into phosphoenol pyruvate. Commonly it is abbreviated as PEP. In the 10th step, this PEP, phosphoenol pyruvate converts into pyruvate. This is considering only the main metabolites. Okay, considering only the main metabolites, these are very short and simple steps of glycolysis. In this case, just after this step, the fifth step, all compounds are 3 carbon compounds. So make it here like this. Okay, in the third carbon, in this case, rearrangement, only the rearrangement, so phosphate will be in the second carbon. Okay, in this case, in the third carbon. For example, 1, 2, 3, 1, 2, 3. In the second carbon, phosphate. And this is also 3 carbon compound. Phosphoenol pyruvate, it is also phosphate. In this case, again, this is 3 carbon compound. So, consider that the first step, only the first step, the third step, and the 10th step, these steps are only one arrow to forward direction, that is, the processes are irreversible. Irreversible. Okay? This symbol indicates what? Irreversible. 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 And if there is two arrow, double arrow, forward, first forward, and the forward arrow and backward arrow, reversible. Reversible. Therefore, the first, the third, and the 10th are irreversible, only to forward direction. In this case, the others are reversible. Okay, reversible. Make all others as reversible processes. So these are only the metabolites, considering the metabolites. Metabolite, that is considering reactants. When you say metabolite, it means reactants and products. So, considering these things, these are the very simple steps. Just you can memorize. Then there will be enzymes in each stage, and also the molecule coming into the process and leaving the process. We will see in the other video. Before that, I want to add here that to catch this, let's use a mnemonic. Mnemonics of glycolysis. Glycolysis. I made it just to simplify the 10 steps of glycolysis. You can make it by your own, just the funny things or the things which you can memorize. Okay? Which is just I made is Google Gates, fan, by Facebook, dearly, gladly, that, a beautiful page of passage is the people praying for. Okay? This is what I can easily capture in my mind, the 11 metabolites. Just glucose, this one, glucose 6-phosphate, fructose 6-phosphate, fructose 1,6-bisphosphate, this one dihydroxy acetone phosphate, glyceraldehyde 3-phosphate, this one for 1,3-bisphosphoglycerate, then this one for 3-phosphoglycerate, this one for 2-phosphoglycerate, and this one is for phosphoenol pyruvate, this one is for pyruvate. This is which is simple for me to capture the 11 metabolites of the 10 step of glycolysis. Thank you. Just please do by your own and put in the comment below for just others will learn from what you put there. Thank you so much.